Hello, this video accompanies the briefing for the Manufacturing Team Challenge national competition at WorldSkills UK Live. This one is talking about the drawings that you need to produce and going to give you a few tips, hints and a demonstration of the standard that we're looking for. Now first of all, I'm going to talk about the creation of the 3D models and drawings a little bit, and then we'll look at something a bit more in depth. If I go to this one that I've prepared before, we can look at this drawing a little bit more in detail. So what we have here is a projection of a simple bar or simple box section, as we can tell from over here, and we can tell the size is 25mm square with a 1.5mm wall. I can see that these two holes are on the center, 100mm apart, and that their diameter is 12. What I can't see from this drawing is whether they go right the way through or whether they just go through one wall. It's not really telling me, and this down here, although it's there, isn't a lot of help. The 3D image again isn't a lot of help, and perhaps I could find a better way of portraying the 3D image. I can now see that it goes straight the way through, but as soon as I put it on any kind of angle, I'm unable to tell. Okay, so I'm going to leave it as it is for now. And we've got a little title block drawing down at the bottom. Now I've deliberately done two pieces that are very similar, and you'll see on this one we've got one hole still on the center, but this time the diameter is 8 and this time it's a little bit lower. Now why have I done that? Well, I'm going to show you really how I would set up things, and the most important thing you can do with the drawings is get the order in the correct sequence to save yourself time. So I'm just going to pop out and get a new one, and I do apologize that my laptop is a little bit slow and it will have to churn a few times. Okay, so I've got a brand new sketch. I'm going to start my sketch on the XY plane, and I'm going to draw a box section profile of 25 by 25. Nice easy stuff to do, shouldn't be a problem. Nope, shouldn't be a problem if you type in the correct dimensions. Let's try that again. Okay, and I'm going to finish sketch, and I'm just going to extrude that now. And this is going to be the first one. So going back to the first one, the length is 350mm, 100mm on the center. In from either end is a 12mm hole. So let's start with 350mm. Okay. So far nothing too taxing. And 100mm in from either end on the center, which is nice and easy. I am going to draw 100 tab, or enter rather, and put in a 12mm hole. And I'm going to do the same on the other end. 100mm and a hole of 12. Now this is where a couple of things start to come into play. In order to make the hole through both sides, because I'm assuming it's going to be something like a bolt running through or an axle perhaps, I can simply extrude and take away. If I do that and I spin round, you can see that this line of extrusion comes out, and it's 350mm. I don't really want that for purposes of this, so I'm going to set it to 25. Now 25 will take it through to the exact. So now I have a hole running both sides. Okay, and that's my first piece. And I'm going to create a save file for this. And file, save as. I can put it anywhere I like. I'll just put it in this design that I'm working on. So I'm going to play box 1. Okay. So box 1 is now 350mm. Okay, nice and easy, and there we go. Now box 2, when I look at it, is 250mm. It's still got two holes, they're both 75mm in, but one is 10mm from this edge, whereas the other is 12.5 on the center line. So I can actually save myself an awful lot of time. Instead of having to draw it all from scratch, I can just save box 1 as box 2. And then I can go into the extrusion here, or here. We'll start with this one. Extrusion 1, change to 250 millimeters. Extrusion 2, I'm going to change the sketch this time, and I'm going to change this to 75, and I'm going to change this to an 8mm hole. I'm going to change this one to an 8mm hole, and I'm going to change this to 75. Now, this one was offset slightly, so I'm actually going to just delete this line here. I'm going to put in a dimension from that center to there, which is 12.5. I'm going to edit that and change it to 15, drops it down, so this should now be 10mm, and finish sketch, and voila, straight away in a few seconds I've changed one drawing into the other. And that's why your drawing order is important. You do not want to be drawing the base profile and the base the base material any more than you have to. So if you can group all your box sections together, all your angles together, all your sheets together, and do them in an order that is very easy to adapt one to the next, you will save yourself quite a bit of time. I've got an example here. This is one that I've been working on with a few other people. So what we have here is 40mm by 25mm box section, 3 pieces, all the same. And I'm just going to zoom in a little bit so that we can have a look at a couple of bits. Now, this piece is the longest, this one's slightly shorter, this one's slightly shorter. Now, this one has a hole here and a hole here, this one has a hole here and a hole here. There are 2 holes, and they're actually motor mounts here and here, whereas this one has 4 holes. Now, the motors are slightly different, and that's why. But is there any particular reason why it's done in this order? 1, 2, 3. This one could become here, and then you could simply chop the ends off this one, and it may, if you're lucky, fit. It may need a little bit of adaptation. So, for example, moving the positions of these holes. Now, that is relative to the distance that those 2 holes are apart. Okay, and if we look, you can see there's 69 in from each side, which is 138 off. So if I take 138 off there, it comes down to 260. So it's not quite that simple, because this one is 280 long. But what we could do is quite easily, just as I demonstrated on the other one, move the holes to the position we want after we've shrunken the extrusion. Okay, so there's a few extras on this particular drawing. We've got the dimensions. I've got a specific tolerance. On each one of these drawings there is a specific tolerance. There is the machine finish that's required. There is a symbol that tells me that all around no finish is allowed, so no surface removals allowed at all. And this one, I've actually got that it's a 19mm diameter hole with a depth of 4mm, which tells me it goes through just the sidewall, which is 4mm. I mean, there's nothing else for it to go through, so... But having said that, we could have just been drilling a hole that was only 2mm deep. We don't know, unless we're specific. A little bit further down, we'll go to the bottom. What we've got here is team name, title, base components, the drawing number. We've got the projection symbol, and that's really important. One of the criteria that you're going to be looking at asks what is the projection correct. Unless you've put the symbol in, we don't know. And if we don't know, we can't give you the mark. We've also got line weight. We've got all dimensions in millimeters and angles in degrees, so that we know what scales we're working with, what units. Chamfers not specified, so if there's a chamfer on the edge of anything like this, it should be 0.2 millimeters at 45 degrees. We have a general tolerance that conforms to the ISO regulations. Yeah? Now, you might choose a different one that conforms to the ISO regulations. You may have your own general tolerance that's specific to you, but it needs to be there. And then what we have is we have 3 pieces of work. The first one, 001, which is this one, base runner, and that's its name, base runner. How many we're making? 5, quantity. The steel, well, the steel is, when we make it, 400mm long, so the raw material is steel at 4mm thick, 25mm by 40mm end profile, and 450mm long, because don't forget, everything has to be 50mm overside. We also have the steel grade. Okay, and that's an example of one way you could do it. The scale comes down in the bottom. We have the sheet at A3. Sheet 1 of 1, you can alter that to be 1 of 1, 1 of 2, 1 of 27, whatever it is you want to do. For the purposes of this one, I've just left it 1 as 1, as it's only a demonstration. Okay, so going back into here, I need to create a drawing. And these drawings here that I've created just as anecdotal aren't very good. If you were to submit those, you'd score quite badly. And if I just pop onto here, you can actually see National Competition Guide, which is a document you will have. This on page 6 towards the bottom gives you a list of what you should be doing. So all drawings must be to ISO standards, but there are also extra requirements set by precedents in the international competition. ISO 5455, for example, gives that scales can only be 1 to 1, 1 to 2, 1 to 3, 1 to 5, and multiples thereof. So if you use 1 to 4, you're wrong. If you use 1 to 9, I'm afraid you won't get marks either. So those are inappropriate scales. Okay, there are two categories of faults for drawings: high and low impact. The high impact marks drop, faults drop all marks for that drawing, whereas a low impact, it works on a sliding scale, and we'll come back to that in a minute. So straight away, high impact fault, missing details for machining. So if I go back to my inventor drawing, do I know what the machine surface finish is on this? No, haven't got a clue. If I go to my original drawing here, you can see that actually, yes, I do know. It tells me surface removal finish rather, 3.2. It also tells me that leave it raw everywhere else, don't touch it. So I've got details for machining. Okay, so back to my list. Missing material. Well, again, on my first drawing, this one, do I know what that's made of? I haven't got a clue. It's not even been rendered in the right, it's just been left in default. So how correct is that? Not very. Okay. Going back to this, missing general tolerance. Well, there's no tolerance that has been put at all on my inventor drawing, so, but they are there on my demonstration drawing, so that's fine. Missing a specific tolerance. Now, you may not need a specific tolerance, but in order to get the marks and ensure you get the marks, put one on, even if it's a daft one. Okay, missing dimensions. Well, there shouldn't be any missing dimensions, and it's really common to come up with a dimension for a hole center missing, or the thickness of material missing. They're quite common mistakes that are made, so please ensure that every dimension is there when you do it. So missing views. This is one that's always open to debate. Do you need 2 views? Do you need 3 views? Now, on this one, I've done 3. It's arguable that this one does nothing, and it really doesn't. And if I put the dimension, take that dimension away from there, and put the dimension down here, then we could argue that actually, oh yes, it does do something now, it gives us that dimension. But does it really? Does it matter? Okay, so on something like this, you would only absolutely need 2 views, and you'd be quite happy with that. But putting in a third will never ever cost you marks, because it can't be said as missing. Some things that you do, you may require 4, 5, maybe even 6 views, although 6 is quite rare unless you're CNC milling. Okay, so going back to this drawing, I've put 3 views in here. Why 3 views in this one? Well, this side differs to this side, so it's probably safer to say, look, they're all there. Okay, but also because of the way the end profiles are set, the whole detail is in the 3rd view, so I couldn't really get away with 2. Okay, back to this drawing, I could get away with 2. Alright, so next one, missing view, wrong drawing. Well, what if you label it guide axle and it's clearly not round, it's clearly square? Is a square going to be a axle? Probably not. So what we're probably going to do is we're going to check the material, we're going to check your costings list and see what the guide axle should actually be made out of, and then we're going to come back saying it's been mislabeled, therefore it's the wrong drawing. All of those things will lose you all the marks for that drawing. Low impact faults. Okay, missing or wrong scale. So there's no scale on the drawing, it should be there, it's automatic, it automatically sets to your base view. Wrong scale. Well, we've just discussed that. ISO 5455, 1 to 1, 1 to 2, 1 to 3, 1 to 5, multiples thereof, up and down. Missing dimension for raw material. So you need to actually put the raw material, and your raw material has to be a minimum of 50 millimeters too long. So you need to specify your raw material dimensions. Okay, so I'm going to just pop back to this one here, 400 millimeters long, and the raw material is listed as 450 millimeters long. Okay, so I can't actually cut on the other two lines because it's stock material, so it only has to be 50 millimeters too long in one direction. It would be a bit different if it was a sheet. It would have to be in two directions. Okay, so stock material, one direction, 50 millimeters over, but I have specified raw material and size. Okay, going back to the list, a little bit further, missing piece number. Now, when you come to do your final assembly drawing, you should be listing all the piece numbers, so every part can be referenced. Now, some of those parts might be sub-assemblies, and that's fine. The sub-assemblies will need to refer back to a drawing. Now, each and every individual part should have a unique number. 001, 002, 003. In this case, you might call them A1, B1, you might call it A, B, C, D, E. I don't know, whatever system you want to use. Okay, so I can clearly see here that 001, which refers to this piece here, is called base runner. Yep, I can check that, it is. The quantity that we need is 5, so I can check in your assembly drawing, is there 5 of them? It's made of steel that's 50 millimeters too long. When we do the toolbox check, we can check that your stock material is the correct size, and we can also check when you finish that you have cut it to the correct size following the rules. S275JR, that's the grade of material. The grade's important. If you use the wrong grade of material, it may not support the weight that you've calculated. Okay, so back to the list. So, missing or wrong scale. Missing dimension of raw material. Those two should definitely be there. Missing quantity. We need to know the quantity you're manufacturing on the drawing. I know it will show us on the assembly, and that's fine, but the quantity should be on the drawing as well. Missing piece number. So we need to be able to reference that piece number to the piece number on your assembly. So every 001 should be 001 on your assembly. Missing projection for the drawings, and we'll just go back to show you that again, and that's what this means. The projection symbol should be there. Now, in the guide, I've actually put down a little note on how to actually draw that, which is right at the bottom where we talk about these. We've got some drawing examples, and right at the very bottom is how to draw the first and third angle symbol and the proportions they should be in. So there shouldn't be any reason for those not to be on your drawings, other than you've missed them, and if you've missed them you will miss the marks. Okay, missing specific roughness. So again, we've put specific roughness on the example drawing. The example drawing shows specific roughness. It also shows that that's where we remove materials, so that's only really referring to the holes or the end cut in this case, and everything else there is no surface removal required or allowed, which means it's just as it is. That's a nice and easy way of doing it. Okay, so next one down, missing piece name. Again, that needs to be there. We need to know what the piece name is, so that again it should be able to refer to it in your assembly drawing, so we can cross-reference everything. And missing line thickness. Now we need to know the line thickness on every single drawing, so those few points should certainly be there. Okay, if I go back into Inventor, just onto box 2, we're just going to run through the simple drawing on this to make sure that you're all happy. And if we just hit drawing, now this is a massive great big sheet, and it's a massive great big sheet because it's on size D. Yeah, so I'm going to go to edit sheet, and I'm going to change size D, and it's up to you what you do. And I'm going to put it in A3. You could put it in A4, it's up to you, but you'll notice that the size down here changes from A3 to changes to A3 from D. I'm also going to go up here, and I'm going to just go to eye properties, and I can now title this however I want to. So what is the title? So in this particular case it's box section 2. Okay. Oh, I've forgotten I've got caps lock on, haven't I? So let's try that again. Not that anybody will mark you down for the misuse of capitals. Okay, so when I do that, it should come up. Author MTC, that's because that's what my computer's called. You might call it Dilbert's Crew if that's the name of your team. Okay. I can also go into project. So part number. In this particular case, 001. Stock number, description, all those other things there. Most of this you don't really need to use, but I'm going to hit apply and close, and up comes drawing number 001, box section 2, Dilbert's Crew. Brilliant. It also comes up with a date, and you don't need to leave the date, it's entirely up to you, but it's a rather nice thing to have. Now, what I'm going to get a crack on with next is I'm going to put the drawing in place, and it's acceptable to have more than one drawing on a sheet if you wish. So a half, that's acceptable, 1 to 2, multiple of. I'm going to put in my end sheet, I'm going to put in my third view, and I'm going to put in my 3D view. Now, that doesn't really take up most of the page, so I'm just going to try it on a 1-to-1. Just move them about a little bit. Does it fit? Well, that one doesn't, but does that one need to? So I'm going to pull this across just a little bit. Okay, and I'm going to do that. I'm going to change the scale of this one because the scale of the 3D view doesn't actually matter, so it doesn't have to conform to the rest of it, and I'm also going to render it. Yeah. In this particular case, what I don't like is I don't like seeing the dotted hidden lines. They're adding nothing to this drawing except for making it look a bit more of a mess, so I'm just going to take those away. Okay. Is this about right? Well, I think I can move that across a bit, and I think I can move that across a bit for the better use of the page. I'm going to sort of centralize this down in the bottom here for now. It might end up being moved up here because we need to add in some extra details down here. Okay, we'll see where we get to. Now this is sort of a bare minimum requirement, but quite an easy one. So, oh, we're on the wrong scales. We're on millimeters. Now I could change it over there, but I'm going to suggest that holes, document settings, and change that to ANSI millimeters is much better. Okay, back to annotate. Okay, so straight away 25mm box. Okay, I'm going to drop in the wall thickness here. Okay, I'm also going to drop in the surface symbol here, and I'm going to just go okay, so all around, no surface removal allowed, hit OK. Why not drop it on that end? It doesn't matter really where I put it, could I put it over here, it doesn't matter. Okay, so this is the part name. So title box section 2. I don't need to now put a part name because I've only got one piece on this drawing. If I had two, I would have to put a title and the number corresponding to them with them. But because I've got it here, box section 2, 001, I could change drawing number to part number. That would be easy enough. What we just do is we go on to here, edit definition, in we go, and I can edit this to say part number, and finish sketch. Yes, and in we go. So title box section 2, part number 001. Might suit your needs a little bit better. I think it does in this particular instance, because now when I'm going back to my list here, I've got piece number or part number, same thing, yeah, and I've also got the title, okay, which is the name of the piece. So I've ticked off this box and this box already. Okay, have I put in a specific roughness? No, but I have put in that you have to leave the material alone, which is quite important in this instance. Yeah. So I haven't put in a specific roughness, so let's do that. Let's do that up here, and surface removal, yeah, and 3.2. Okay. Missed something, didn't I? So we need to edit that and tick. Okay. So there's our correct symbols for this particular drawing. Now that means that we've ticked yet another box. Okay. So dimensions. Put them in as quick and as dirty as you like, and however you like. Your choice. But we've got them on the end there. We've got them on that there. My first protocol that I nearly always forget to do is should be center lines, and from there to show that's in the center, create. Okay, so now I can dimension that a lot easier because I can just go from there to there, 75 millimeters. I can go from there to there, 75 millimeters. There is no need to do that one because we've already said it's in the center, and this one is at 10 millimeters there. Okay. Now, a couple of little debatable points. A lot of you will be tempted to just simply go 8 mil, okay, and maybe 8 mil, okay, and I like to do that. If I do, it saves a bit of space, looks a bit neater and a bit snazzier. So, but I'll probably put it in the center a bit better. Yeah. Okay. But is that correct? Well, we know there's a hole there of 8 millimeters diameter, and it's round. But that's all we know. We don't know the depth. Does it go through both pieces? Does it go through one piece? We haven't got a clue. So, what you should be using, and I do apologise because my laptop will take forever to do this, is the hole and thread tool. In this particular case, when it comes up, it will actually specify how deep the hole is. Now, if I know the depth of material, I can tell if that goes through or not. And that was why it was important when we drew the actual drawing that we extruded to the correct depth and not any depth. Okay, there is a big distinction. If I'd have put any depth when we do the hole and thread, it would have come up as 25 mil. So I'm going to say that's an 8 millimeter hole. Yeah. And I can still do exactly the same here. I can still overlap them. There we go. Okay. Now, 8 millimeter hole diameter at a depth of 25 mil. That's right the way through. Okay. If I'd have left it at 350 mil, this would say 350 mil here, and you'd have somebody going out trying to find a 350 mil drill bit so that they could actually drill 325 millimeters of air. So absolutely pointless. Yeah. So we try and get our depths right. Now, is there anything missing from the dimensions on there? And I'll just give it a quick look over, and I think we're pretty much there. We will go through our checklist though. Okay. So bringing up our checklist. Missing details for machining. Machining does include drilling, so that's correct. Yeah. Missing material. No, we don't have material. So we need to go down here. And again, I'm actually going to clear this title block. And you can do this any way you like. Your own title block. Use the ISO standard one as I've done. You can do what you like, really. Just so long as the correct information's there. So ANSI large. Oops. So let's try again. ANSI large, edit. Okay, so I'm going to go up into here and I'm going to delete that. I'm going to delete that, delete that, delete that, delete that, delete that, delete that. I'm actually going to change that to team name. Okay. Is there anything else that we can delete here? I think it's all pretty much there. Company we don't need. We're going to use that box for something else. Okay. So yes, let's save that. Okay, so we've got Dilbert's crew. Oh, Tema name. We can go back in and change that afterwards. Okay, so have we got everything that we need, and have we got space for everything that we need? We've got to go through the checklist. Okay, so details for machining, missing material. So we're missing the raw material. So what I need to do is I need to create somewhere to write that on here. So I could simply state raw material, caps lock still on, raw material, yeah, and it's box 25, times, it's 250 mil long, so it would need to be 300 millimeters. What grade? SR275JR, for example. Now, does everybody know what that means? No. So what we actually need to do is put grade SR275JR. Probably in capitals would be better. Okay, what that doesn't tell us is what the wall thickness is. So I'm going to put thickness 1.5 times, I'm going to put times there. Okay, so that's pretty much telling me what the raw material is, but it doesn't tell me what it is. Okay, so raw material, I need to put in steel. Oops. Steel. Okay, and we now have our raw material details. Yeah. Now, if you're doing two, you're going to need to say which one is which, and you're not going to need to do it twice or three times, depending on what's on there. Okay, so back to that, we've got missing material. So missing general tolerance. So what's the general tolerance? Well, we can do anything we want, really. There's no specification. You could use the ISO ones as I did in the demonstration, or you could just put general tolerance bidding, and up here we can have plus or minus 5 millimeters, because that might be the case in this one. Yeah, you might be asked to specify done it again. You might be asked to specify where you came up with the tolerance from, just to justify it a little, but not very often. Mostly it's accepted that if you put it there, it's got to be for a good reason. Okay, so now we've got a general tolerance. So I'm going back to this one. Missing specific tolerance. Okay, so looking at the drawing, do I have any specific tolerances? No. So let's open this particular one up. And let's put it in a specific tolerance. Now I'm going to put symmetric this time, and I'm going to say it can be plus or minus half a millimeter. So now I have at least one specific tolerance. I might be able to tolerance something else. I might want to tolerance it all. It just literally depends on your design. Okay, but now I have at least one specific tolerance, so I've ticked specific tolerance. Missing dimensions. Well, let's just go and have a look. Can we see anything missing? We've got the size of the end profile and the width. We've got the distance for this hole both sides. We've got the distance for this hole both sides. We've got the size and depth of the hole, and we've got the overall length. So I'm pretty confident that I've got all the dimensions there. Okay, on to the next one. Missing views. Well, arguably, I've got one extra. This one doesn't need to be there. Okay, I could have put the 250mm up on here, and this view is then absolutely superfluous. But it's there. No reason to get rid of it at this point. Wrong drawing. Well, so long as this is box section 2, and the piece that looks like that is called box section 2 or part number 001 in your assembly, it should have both, let's be honest. And we can say, yeah, no, that on the assembly, that's correct, then there's no way that this could be the wrong drawing, or it shouldn't be the wrong drawing. Okay, so now we can go on to the low impact faults. Missing or wrong scale. So the scale is there, the scale is 1 to 1, it's not missing. Is it the correct scale? I would say it is. Looking at that A3 sheet, look at the size of an A3 sheet, 250mm long, that looks correct to me. That's number one. Number two, it's a scale that meets the ISO 5455. Next, missing dimension of raw material. Well, funnily enough, we covered that here. So raw material, steel, we gave it all the dimensions. You can tell what dimension you cut it to, and we gave it the grade, so that's all there. Okay, missing quantity. Now, how many of these are we making? We don't know. So let's pop down into here. and we're making 6,000 of them, which is going to be a pretty hefty personal transport vehicle if we do, but you never know. Okay, it's possible. On to the next one. Missing piece number. No, I think that's there. Yep. Part number, piece number, label it how you like, it means the same thing. Mouse not working. Missing projection for the drawings. We are. But specific roughness we've got and piece name we've got. So what we're missing now is line thickness and drawing projection. So I'm just going to go back into here, and I can do this in one of a couple of ways. For line thickness, I'd rather go into this box here. So I'm going to go, come on, I think, there we go. Okay, so I've now put my line thickness down there. That's easy enough. And then this one I need to put the projection symbol into. So are we using first or third angle? Up to you. Yeah. And I'm going to go back into the title block and back into the title block there, and I'm just going to do a couple of edits here. What I'm actually going to do is get my trim tool, and I'm going to take these lines away, and I'm actually going to go finish sketch just to check it. Just save. Now what's that done? Well, it's opened up this box, but I could do with this box as well, really, couldn't I? So let's go back into edit. Yeah, and these don't need to be there, they're just in my way. Check date no longer applies, creation date does. So trim, and let's remove these completely. Now once I've created this template once, I shouldn't have to create it a second time, because what you should do is just save it as the next name and import the next part onto it. So I'll show you what I mean by that in a second. So while I'm here, I'm going to go sketch. Sorry, I'm just going to check my sketch, but I'm actually going to create, and I'm going to say 10, like this, and that's my nice little drawing. I'm then going to scoot in a little bit, and I'm going to pull a line from here to there, and oops, forgot something. Forgot the middle one, didn't I? The middle of the projection symbol might be useful. So I'm just going to tie this to that, and tie this one there, and then I'm going to drop across here and line this up with here. Bring it back in. No longer need this line or that measurement. I'm going to bring a straight line now from here to in line with here. Made a bit of an error here, look. I'm just going to redo that line. Pop it out. I'm going to get rid of this and this. I'm going to go to annotate. I'm going to put a center line in this one. Not going to let me do it. I'll go back to sketch, finish sketch. Okay, so there's my projection symbol. Now I can now start to annotate this, but it won't let me because it's a sketch in there. Okay, so I need to go back in and finish it really, and I'd like to show you that because it's a bit of a quirk and it's rather annoying that you can't do it. So I'm just going to get these out of my way, and the way I normally do this, just to make my life easier, is I go up and stop that a little bit short. I do exactly the same there, stop it a little bit short. Line over here, stop it a little bit short. Ooh. Just the other side to there. We put a long one in, we put a short one in again. You might want to make it about the same length as the other. And is anybody going to pick up that these aren't the correct centre lines? And the answer to that's not really. Nobody's going to be bothered. They know what the symbol means. It's there. It's good enough. But if you want to draw exacting and use exacting centre lines, you can be my guest. Nobody's going to stop you doing that either. But this is kind of a quicker way of doing it. Okay. The other thing we need to do is we need to write projection. Okay, so now I can finish sketch and save that. Okay, and that should now contain absolutely everything. So just going back through it, we've got the line thickness, piece name, specific roughness, we've got the projection for the drawings, the piece number, missing quantity, we've got the quantity, we've got the dimensions of the raw material, we've got the right scales, we've got details for machining, symbols, we've got the material there, general tolerances there, and the material I should add has got the grade as well. We've got a specific tolerance at least, we've got all the dimensions, we've got the correct views, and it is the correct drawing. That should give us the maximum mark. And going back to the copy of the National Competition Guide, that's all written down here. It's all there for you to follow through, and it talks about absolutely everything. It also goes on to show you how to deal with the 3D assembly drawings. Okay, so just going back to this then, would that score highly? Well, yes and no. It would score absolutely everything on your yes-no criteria. Judgment wise, it may or may not, and there's two things wrong with it, and I can solve one by going back into box 2, and I go to tools, material and appearance. Now I've said it's steel, so why doesn't it look like steel? That's the first question, and the answer is because I haven't set the material to steel. Now there's several ways of doing it. This is just a quick easy one. So what type of steel is it? Just steel will do. Okay, now if I save that and go back into my drawing, the finish on the steel should have changed. It hasn't. Why hasn't it? Because steel looks an awful lot like it probably. Okay, but it's changed and we can actually go in and look at that and it is correct. Yeah, that's one thing. The next thing, well, I said about this drawing here and I wasn't sure if it was going to take up all the space, but a good use of space on a judgment. Now that doesn't quite fit. Okay, but remember I said the drawing scales matters, the 3D doesn't. Okay, so I could change 1 to 0.8, 0.8, sorry, yeah, and it gets too big. So 1 to 1.2, and it fits perfectly. Okay, so now what I've actually done is I've completely filled the page. Now does that look a little bit better than not filling it? It's arguable, but it's going to depend on the judge's particular opinion. Yeah, but what the judge is looking for is they don't want something tiny up in this corner and everything else empty. They don't want something non-existent over here, or they don't want things disjointed. They want things laid out nicely and clearly. These dimensions here, if you had it there, for example, does that look as good? Aesthetically, that's quite difficult. You're overlapping things, so we would never do it. We'd always bring it down. Something else they might look for is, why would that be over there and not in the center? Yeah. Something else they might look for is up here. You might have this. Now, is that incorrect? It's not incorrect at all, but the drawing just does look that little bit neater and that little bit happier when they overlap like that and both go. Now again, that needs to be somewhere near in the center. Okay, so it looks a little bit clearer. You could argue as well that perhaps this needs moving up a little bit away from there just to make better use of the space again and show what should be done properly. Yeah. Okay, does that look a little bit clearer? Over here, why have I put 25 box? Well, it saves a second dimension there. Is a second dimension there wrong? No. But let's have a look. If I put in a second dimension there, which one do you think looks better? And it's a matter of opinion, and actually neither are wrong. Okay, so you could have 25, 25, or you could just put 25 box on one of them. I prefer to put 25 box on one of them. It leaves the page just a little bit cleaner. Yeah. Okay. So that's pretty much it for the drawings, and that gives you a good example of what we expect for a 2D drawing. 3D drawings are pretty much similar, and just to take you through what we're looking for on the list, we are looking for a similar or same text box. We are looking for all of the things that were there in that drawing to be correct, as in, is it the right part number? Is it the right part description? We're looking for sequential non-repeated numbers in your drawings. So you might have a sub-assembly that uses part 001, part 002, part 003. You then can't go on to a main assembly with part 001, 002 and 003. It would have to refer to the sub-assembly, which might be called 004, it might be called sub-assembly 1 or sub-ass 1 or any of the other things. But when you actually put it in, it needs to be consistent. So if we refer to sub-assembly 1, we can go to sub-assembly 1 and see the parts that are in it, and then when you put any new parts into the main assembly along with the sub-assemblies, they should not have the same numbers, and no two sub-assemblies should have the same numbers. So each number for each part needs to be unique. Okay? Alright, so other than that, take a look through the guide here. It does show you a few examples of how this, for example, is there anything wrong with it? Yes, we're missing dimensions left, right and center. This is a bit squished in. Title blocks not filled. And this is a kind of typical drawing that we get. This is maybe a bit large, it's touching on the edge there, it's missing down to the center. That's a kind of typical drawing we get from MTC competitors. It's right, you could use it, but it's not quite right, so it's not getting all the marks. Okay, so there is no height or center lines for the drilled holes. The holes may or may not go completely through the part. Nothing tells me. It has the correct views but does not have a pleasant layout. The 2D parts are squashed together and the 3D parts are too large. No specific tolerance. All of the hole diameters are missing. So that's the kind of things we come across all the time. So we've improved it ever so slightly, and this is one option. It now says diameter 8 through. Through, yep, we now know that goes through. It's box section. Does it go through one side? Does it go through two? Okay, we've got a height though, 12.5. Arguable, very arguable, that as long as you put a center line in there, the 12.5 doesn't need to be there. And that 25 is the same as that 25, so why is that there? Okay, looks a bit better now. We've shrunk this down, it's not touching against there or here. Text box still isn't full. We have the machining symbols applicable to it. Okay, so everything's now dimensioned, we know where they are, changed the size of the 3D models, allowed for the 2D drawing to be spread out better. There's now a specific tolerance. Let's go and check that. Oh yeah, there's one here, look, 300 plus or minus 0.1. Okay, the holes now have sizes and we know they go through the part because it says through. Yep, great, we're happy with that. Also added are the symbols for surface finish and machining finish. Yep, here we go, they're right here. And the 25mm given on the left hand side is not needed, there's already another one on the projection which is over here. And this is the kind of thing we hone in on and see in pictures very quickly and very easily. It's a little squashed, but the scales now comply to 5.4, 5.5. Yeah, a smaller scale could be used and a second part added, that's fine. Okay, so again, ignoring the title block, what have we got here? Okay, so we've made a couple more changes. We've removed the 25mm from there and there, and we've put 25 box. Now notice it's not so squashed anymore, is it? It's a little bit freer, a little bit easier, and a little bit clearer to see. Okay, so that's nice and easy, yeah? But on this one, what have we done? The 4th generation, we've now added a general tolerance here, yeah? And this is one that's just made up by me. And you can do the same. We've got line weight, we've got quantity, we've got the name, we've got stock material. Everything now is there. That would score reasonable marks. And it's only a subtle difference in reality from there to there. A lot of people wouldn't be able to tell the difference particularly. They'd be quite happy with either. But when you come to make this part, you can't make it, and that is a critical criteria. Can I make the part using the drawing? And the answer to this one is not on your Nelly. I know roughly how to make the part, but I can't be accurate. With this one, can I make the part? Yes, I can make the part. Great. Critical question answered. However, is it a pleasant drawing? No. Is it an accurate drawing? No. We try and put as minimum amount of information we can get away with, and that isn't the minimum amount of information, it's duplicated information. In fact, we've got the 25 3 times when we can have it just once. Okay, so we move on down. Can I make it from this? Yes, every single dimension I need is there. I know where that line is, I know where that line is, 6.71, I know that's 25mm box, know the wall thickness of the material, I know the tolerance here, I can make that part. That is absolutely great. However, you're going to lose marks, lots of marks, because there's no title block. Drawing has a title, one of the critical criteria, it's not there. So when we go down to here, it's the same drawing, but this time title block's finished. Should be awesome. So hopefully that will actually guide you to make the drawings to the standard we're looking for at WorldSkills, not just UK but actually international standards, and they are pretty similar, a little tiny bit more. Hopefully it will give you some tips on how to create your drawings a little bit quicker, perhaps by grouping your parts together and putting them in a sequence. That means a minimum adaptation of part 1 becomes part 2, minimum adaptation becomes part 3, part 4, etc. Okay, and also a little bit about how to just alter your title block and make sure you're getting it. So keep referring back to the previous video that you got the link for this from, the one that actually tells you all about this year's project, and have a look out also for the qualifiers. Now this in particular will be hot for the qualifiers this year, and this video is very, very useful to use for that. Thank you very much, and hope to see you all at the national finals.